Good afternoon and welcome. In this video, I am going to discuss basic time series data analysis and forecasting. A time series is a set of observations on a quantitative variable collected over a period of time. Businesses are often very much interested in forecasting time series variables because more often independent variables are not available to build a regression model of a time series variable. In time series analysis, we analyze the past behavior of a variable in order to predict its future behavior. One of the methods used in forecasting is regression analysis, a statistical technique that uses time series data for explaining the past or forecasting future events. The prediction is a function of time in terms of days, months, years, etc. And there is no causal variable. Examine the past behavior of a variable and attempt to predict the future behavior. Components of time series analysis. The question is, how far can we predict? There is a short term in which we discuss 1 to 2 periods, and medium term involves 5 to 10 periods, and long term involves 12 plus periods. So the first component of the time series analysis is trend, which is a gradual long-term movement up or down of demand. It is easiest way to detect. Then there is a cyclical variation, and cyclical variations are an up and down repetitive movements in demand, and these movements repeat themselves over a long period of time. Then we have seasonal variation in time series, and these are also an up and down repetitive movement within a trend occurring periodically, usually within 1 year. Often weather related to, but could be easily or weekly occurrence. And the last component of the time series is random variations. These are erratic movements. These are unpredictable and random, that are not predicted because they don't follow a pattern. This is how a time series look like. This is time series plot, and the variable is sales in $1,000, and these are plotted for period of time. Components of time series analysis. These are difficult to forecast because there are no causal variables. The components that is trend, seasonality cycles, and random variation cannot always be easily and accurately identified. There are certain terms which are used in time series: stationary, and there are non-stationary data, and there are seasonal data. And seasonal data are a time series variables exhibiting repeating patterns at regular intervals over time. How to approach time series analysis? There are many different time series techniques. It's usually impossible to know which technique will be the best for a particular data set. So it is customary to try out several different techniques and select the one that seems to work best. To be an effective time series modeler, you need to keep several time series techniques in your toolbox. Measuring accuracy. We need a way to compare different time series techniques for a given data set, and these may be means absolute deviation, mean absolute percent error, the mean square error, and root mean square error. And in this presentation we will focus on the mean square error, that is MEC. One of the methods or models is extrapolation, and these models try to account for the past behavior of a time series variable in an effort to predict the future behavior of the variable. And this is an example. There is Electricity, which is a retail store that sells audio and video equipment for the home and car. Each month the manager of the store must order merchandise from a distant warehouse, and say for example currently the manager is trying to estimate how many VCRs the store is likely to sell in the next month. So he has collected 24 months data, and here is the plot of the time series data. So that is the moving average. Moving average is one of the way. So y hat t plus 1 is the target for using moving average as a forecast value. So no general method exists in determining k. So we must try out several k values to see what works best. This is how to implement the model. So we have number of VCR sold. This is 2-month average. So if we sum up these two and divide by 2, we get this value. And this is the 4th month average. So here, this blue line is the actual number of VCR sold, and this red line is the 2 months average, moving average, and this green line is the 4-month moving average. So this is how we forecast data using the moving average method. A comment on comparing the mean square error value. Care should be taken when comparing MEC values of two different forecasting techniques. The lowest MEC may result from a technique that fits older values very well but fits recent values poorly. It is sometimes wise to compute the MEC using only the most recent values. This is how we forecast with moving average model, and forecast for time periods 25 and 26 at time period 24. So this is how we can forecast. So we sum up the variable for 24th and 23rd observation and divide by 2. So we get 35.5, and this is the forecast value for 26th observation, and that is 35.75. This is weighted moving average. The moving average technique assigns equal weight to all the previous observations, whereas the weighted moving average technique allows for different weights to be assigned to previous observation. So we must determine values for k and the wi. This is how we implement the method. So here we have the actual number of VCR sold, and then we have in the pink 2-month weighted moving average, and here are the weights. W1 is 0.05 and W2 is 0.05, and sum is equal to 1. So this the MAC is equal to 6.93, and these are the 2-month weighted moving average. This is using optimal values for the weights that minimize the MAC. So again, here we have 6.29 as MAC, and these are the graphs of the actual number of VCR sold and the 2-month weighted moving average. Forecasting with the weighted moving average model. So these are how we can forecast values for 25th time period and 26th time period. This is exponential smoothing, and it can be shown that the above equation is equivalent to the below equation, that is yt plus 1 hat is equal to alpha yt plus alpha into 1 minus alpha yt minus 1, and so on. This is examples of two exponential smoothing techniques. The blue one is the number of VCR sold, and this black line shows exponential smoothing where alpha is equal to 0.1, and the green line shows exponential smoothing when alpha is equal to 0.9. And this is how we implement the model. And this is forecasting with the exponential smoothing model again. And this is now seasonality. As I mentioned earlier, seasonality is a regular repeating pattern in time series data. These may be additive or multiplicative in nature. These are stationary seasonal effects. There may be stationary data with additive seasonal effects, where ET is the expected level at time period T and ST is the seasonal factor for time period T. This is how we implement the model, and here we have graphs of these variables. These are the level, these are the seasonal factors, and these are the forecast values. This is forecasting with additive seasonal effects model. So forecast for time period 25 to 28 at time period 24 is like this. So y24 plus n hat is equal to e24 plus s24 plus n minus 4, and we can calculate these values using these equations. This is stationary data with multiplicative seasonal effects, and this is how we implement the model. There are some graphs and the forecast values. These are forecasting with the multiplicative seasonal effects for 25th up to 28th time periods. And these are trend models. Trend is the long-term sweep or general direction of movement in a time series. It could be an upward or downward trend over a long period of time. So we shall now consider some non-stationary time series techniques that are appropriate for data exhibiting upward or downward trends. This is one example of upward trend, which is the actual sales. This is quarterly data from 1998 to 2002. This is double exponential smoothing, and this is Holt's method. And this is how we implement this model. Alpha is 0.5 and beta is 0.5, and MEC is 70,179.3. And here we have the actual sales and the predictable sales using these formula. This is using optimal values for alpha and beta that minimizes the MAC. And here we have the actual and the predicted sales, and these are the predicted sales. This is the trend. Here we have forecasting with Holt's models. Here we have how to implement the model. This is the linear trend model where yt hat is equal to beta naught plus beta 1 x 1t, and this is how we implement the model. This is the trend function, and this is the quadratic trend model in which we have t and t square. This is how we implement the model. This is forecasting with the quadratic trend model, and then we have seasonal regression models. Here we have indicator variables that may also be used in regression models to represent seasonal effects. If there are p season, we need p-1 indicator variables. This is how to implement the model using the regression function, and here we have the data. Then we have the regression results. This we can do easily in Excel or SPSS or eViews or Stata. This is plot of the actual sales and additive seasonal models. This is forecasting with the seasonal regression model. This is combining forecast. So ladies and gentlemen, this was a brief introduction and basics of time series data analysis and forecasting. This is the theory with some examples, and in next videos I will use some hypothetical example of hypothetical data, how to forecast these models. I hope this was quite informative and useful for you. Kindly do subscribe to the channel, and do not forget to click on the bell icon so that other people can also get information. Thank you very much for watching this channel and video.